Good.
Alright, hey guys, this is the start of my first reaction, and that'll be the elephant's toothpaste reaction. It is also known as the decomposition of hydrogen H2O2, also known as hydrogen peroxide. The way this reaction works is the potassium iodine, when it mixes with the hydrogen peroxide, it decomposes it down into oxygen and water. Usually this happens over a very slow amount of time, days, weeks, and sometimes even months if it's in a perfect condition. But with this, potassium iodine, we'll be able to do it in just a few seconds. So that's what we'll be doing. So see ya when the reaction happens.
Okay. Go ahead.
It's around 10 milliliters of hydrogen peroxide. And we'll do another 10 with our eye dropper.
Go ahead.
Okay, so this is we're going to be doing the reaction right now. This is our base reaction. We're going to be recording a few things. The heat during the reaction, once the reaction is over, I'll take it out. pH after reaction. So after the reaction is done, we'll do another pH test. We'll also do a weight difference. We'll measure the test tube after the reaction. It's probably lost a lot of weight. Then we'll finally do a visual difference from the base reaction. Well, this is the base reaction, so we won't have to record anything. So, I'll give you a countdown. 3, 2, 1. Oh.
Oh.
Ooh, it's warm. Okay, so I'm going to let that sit for a little while since it seems like it's still reacting. Take this out now. It smells very like pool water.
Does it?
So the temperature is 41 degrees Celsius. Hot. Look at that foam. It's funky.
Can I stop? Can I stop
You
now?
can stop.
Okay. Okay, I'm going to just leave that off to the side.
That's amazing.
I'm going to go around the other side. Okay.
Just put your hands close to it. Feel it. You can feel how warm it is.
Yes, and I can smell that pool water smell that you're talking about.
It's probably the hydrogen peroxide and soap combining. So now we want to test the heat after a while. So now we want to test the pH. So I need to quickly wash off my hands somewhere.
Go ahead, in the sink, it's fine.
In the sink. In the side.
This side here. Okay.
So you don't mess up any of the results.
I'm watching you clean up too. And then when you clean up, I'll stop now, and then we'll come back in a sec. Okay.
Hey, so this is test number 2. We'll be doing it cold. We've cooled down the solution of soap and H2O2, and it's now just we're about to test its temperature, and then if it's just the right temperature, we're going to do the reaction. Okay, here it goes. We'll leave it in for about 10 seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We should probably, yeah, that's good. It's probably just didn't get an accurate reading. About 15 degrees Celsius. So now we'll pour in the potassium iodine, and so 3, 2, 1. Uh-oh. Technical errors, but we'll see what the reaction does. Oh, that's it. The reaction is definitely a lot less violent, and it's not absorbing all of the liquid. It's very interesting. Let's check the temperature. The temperature is mere 20 degrees Celsius. So, 20 degrees Celsius, we'll let that finish and we'll take the pH. So, okay, a very interesting difference.
And go.
Hey, so we're just about to start the hot reaction. As the results of the last reaction showed, heat does have a lot of effect in these kinds of reactions, so we're going to take a look at how hot affects this reaction.
Okay.
Let's get it out of there. Let's see the temperature. Very warm already. Thermometer still rising. It's 30 degrees Celsius.
Okay.
Okay. So I'll give you a countdown. 3, 2, 1, go. I'll tell you when to stop. Oh, we don't have that in there. Still reacting. Stop. Okay, let's get a temperature reading. 35 degrees Celsius, a bit colder than the first reaction. I can feel it's quite a bit colder than the first reaction. It's not like piping hot.
Mm-hmm.
It's okay, now let's do a pH test after I just wipe my hands off a little bit. Right down 2.5.
Okay.
So, we're going to be doing our second reaction. That is combining zinc and hydrochloric acid. Here we have all the things we need to do, measurements, proper, making sure my variables are correct, and all the chemicals to actually start the reaction, and everything to actually make the reaction happen. So how this will work is pretty much similar to last time. I'm going to do all pre-measurements, such as pH before reaction and possibly weight before reaction. Then I'm going to do my reaction, take my weights and everything during and after the reaction, record those results, and then I'll do it twice again with different heats to see how it changes. I don't think the differences in this one will be as noticeable as the elephant's toothpaste, but you never know. Okay, so we're about to start the second reaction, which is, as I told you, HCl and zinc. This is the zinc in this little petri dish, and that is the HCl in the cup. So what I'm going to be doing is I've already taken it outside natural temperature, which is around 16 degrees Celsius, and I'm going to pour this in. Since it's an exothermic reaction, it produces heat. We'll see the temperature change and see how much it changes, and we'll take all of our other samples and we'll see how it goes. So, I'm going to do a little countdown. 3, 2, 1. Awesome. So you can see the temperatures are already skyrocketing. 70, and it's still climbing. 75. Seems like it's about to stop. Slowly climbing still. So that's hydrogen gas being produced at the moment. Let's give it a little stir to try to expose a bit more of the zinc. So right now what's going on is it's doing a chemical swap reaction. So basically, the hydrogen and the zinc are swapping places. It's creating a hydrogen gas, which is coming off it right now. It's also creating zinc dichloride, basically a compound that we'll be using for the next reaction, which will be tomorrow. So yeah, we'll just let it react, and it seems that it peaked at around 77 degrees Celsius. Hot, hot, hot. So we'll let that finish reacting, and then we'll take the pH.
Is the timer going?
And yeah, the timer's still going. It's still reacting.
Okay.
Hydrogen gas is still
pH?
being produced.
pH?
No, that's after, remember?
Okay.
Let me mix it around a little bit.
Okay.
Oh well, Mom will be here for the next one.
Okay, gonna stop?
Okay, but not the timer yet. It's still
No.
reacting.
You want to talk about what's going on?
Hey! Are you filming?
Yeah.
Oh, okay. So we just finished our reaction outside. Once it stopped reacting, we brought it inside. We filtered out all the zinc, as you can see there, and now we're letting the zinc dichloride, leftover zinc, filtering out all the zinc dichloride until it turns into a crystal, and then we will have the part for our next reaction.
What's the gas that's coming out of the container now when it's
That's
heating
just
up?
vapor.
Just vapor?
From outside. It's how
Okay.
cold it was.
Okay.
We can cap it off if one's feeling nervous.
We're good. But we need to charge our camera after this go for a bit. Okay, I'm gonna stop filming for a while, Ryan.
Get the bubbles. They were nice and close to get the bubble reaction.
At the bottom. Yeah, so I can see it. Okay, so catch you after.
Bye!
Bye.
Okay, I'm gonna drop it in 3, 2, 1, dropping. Definitely still pretty foamy, but a lot less. It's not as violent, so let's put the thermometer in, get readings.
We're gonna go up. It's up to 40 already.
40,
50.
50, 60, 65. Seems like it's stopping.
Did it hit 70?
It's about to. It hit 70.
Okay.
I don't think it's gonna go up anymore. You can see like the bits of zinc floating around. Yeah, it seems like 70 was the peak.
Okay.
So, Mom, could you write down 70? Temperature during reaction 70. So we'll let that go.
Yeah, the reaction is done a lot faster.
Yeah. Before it was like still bubbling at this point.
It was.
This is like how it was like after 6 minutes, Thomas.
Yeah, that's right.
So it's definitely a lot slower. I'm seeing a trend here. So it's definitely, because the amount of energy that's needed has to be higher for a reaction to occur, and this is lowering the amount of energy that's actually there, so that could be one of the reasons why it's reacting a lot slower, because there's a lot less energy at the start.
We'll be able to prove that tomorrow when we do it warm to start with. How's the reaction? Still going?
It's still going, although it's dying down.
Looks cool, right?
Thank you. Yeah, we'll filter it out, and then we'll heat it up, make more crystals in the same container as that one. A little bit left, but not too much. Let's see how many grams are left over.
Tell me when it's finished. And I'll start the timer.
Oh, I shouldn't have anything on it.
Is it done? Tell me when it's done.
I'd say that's done.
Okay. And I'll stop my movie.
Hot hydrochloric acid. In 3, 2, 1, go. Timer's going.
Yeah, it is.
Thermometer. Just put it in there. It's rising. 60, 70, 75, 80. That's a big difference.
Yeah.
84. It seems like it stopped. No, 85. 86. Seems like 86 is the limit. And it's still going. It's not dropping. No, it seems like it's hit 87.
So what was the max?
The max seems to be 87. So
Okay.
it's a 10 degrees temperature increase from the base reaction.
Okay.
And I don't know, we'll check the video footage on this, but it seemed to be quite a lot more violent than the first time.
I think it did.
Temperature's definitely lasting a lot longer. So we'll do a time of that, and yeah.
Okay. Need to go this way because of the shadow. this.
Give it another swirl.
Sure.
A big chunk of it. I'm gonna try to break it up, that big
Okay.
chunk. Still going. Let's see the timer. It surpassed the cold one.
Yes, for sure.
It's still going. Give another swirl. I don't know if the camera can see that, but it seems like there's
Let
some
me go around
form
this
of like substance on the walls of the beaker.
Okay, I can't stand there in the light. I can see the substance. Okay, no shadows. There's still a big bubble in the bottom. I see it.
Give it another mix.
Okay. It's starting to slow down the reaction, looks like. There's still smoke or vapors coming out of the top.
Yeah, that's the hydrogen.
I don't know if the camera can catch it, but
Yeah, they're pretty faint. I don't think the camera will catch it.
maybe. It's pretty bright out.
Well, it's still going on.
Yeah.
4 minutes.
Is it okay if I stop?
Sure.
Okay, I'm going to stop. And I'm going to record the temperature. So, anything you want to say?
No, then other than I'm surprised with the results. I thought it'd be a huge difference, same with Elephant's toothpaste, but it turns out it's just most likely going to go on for a little bit longer, and it was a little bit more violent at the start, so see you later.
And I, step bottles and stuff like that.